Welcome to part 6 of our series on quadratics. Now in this video we're going to explore the quadratic formula. We're going to look at the different outcomes from the formula, some aspects of it that you may not yet have thought about. We're also going to look at the relationship between the results from the formula, the graphs and the solutions or roots of the equations that they relate to. Now, if we start with the information at the top of the screen, you've got the general form of the quadratic formula that you need to be familiar with, which is over here. You've got the general form of a quadratic equation, which is here. Okay, and you should know that the square root of 0 is 0, that the square numbers are 1, 4, 9, 16, 25, and so on. You should know that the square root of a number that's negative is not a real number, okay? And this will be new to you. The discriminant is defined as the bit of the quadratic formula that's under the square root symbol, the b squared minus 4ac, and we give it this symbol, this delta symbol, the discriminant, and the significance of that will be discussed during this video. Now, on the left of the screen, I have 4 different quadratic equations, and their graphs are plotted on the right here, okay, in the corresponding colors. Now, of course, you'll notice that they all have the same x squared coefficient of 1, so that's the value of a in the general form, and the b, or the x coefficient, is -2 in all of them. But what's different, of course, is the constant at the end, which changes the value of c. Now, in the first one, c is -3, and you will notice that its graph crosses or intercepts the y-axis at -3. The second one, -1, intercepts at -1. The third one, +1, and intercepts at 1, and so on. Okay, so the effect of changing c is to translate the function vertically up or down. Okay, and finally I want you to notice the numbers of solutions that you see for the quadratic equations when y is set to 0. Okay, so consider the equations as being when y equals 0. So, for example, x squared minus 2x minus 3 equals 0, and so on. If you look at the 4 graphs on the right, okay, they each have different properties when it comes to crossing the x-axis. So the first one clearly crosses the x-axis in 2 places, and they appear to be at -1 and 3 exactly, which is where they are. Okay, the second graph, the blue one, also crosses the x-axis in 2 places, suggesting that it has 2 roots or solutions, but it's not obvious where those 2 solutions are. The third one, the green one, that appears to sit on the x-axis but not cross it, suggesting that it has just 1 solution or 1 root. Okay, and the orange graph, well, it comes from infinity, it comes down as low as 2 and then goes back off towards infinity again and never meets the x-axis or crosses it at all, suggesting it has no real solutions or roots. Okay, well, we're going to explore all of this in the next few minutes. Now, first of all, I'm going to solve all 4 of these using the quadratic formula. It is the case that 2 of the 4 equations here could be solved by factorizing, but I want to start by looking at solving them using the quadratic formula. So I've already prepared the substitutions into the formula to save time. Okay, so in each one, all I've done here is I've replaced the a, b and c in the formula with the numbers 1 for a, -2 for B in all cases, and for C either whichever of these it is, -3 in the first one, -1 in the second, and so on. All right, and then that's just saved a bit of time, and I've used the convention of replacing the letter with the relevant number in brackets. Okay, so it could be entered onto a calculator exactly like that if you wanted to. So here we have that B is -2, so I've put that in there from the formula, and C is -3 and A is 1, you see. Now if you evaluate that or simplify it further, I've also done that for each of them to save some time, and those are the results that you get. You can check them out if you want to. Okay, but that's what you'll end up with for each of those four substitutions there. Okay, now these can actually be simplified further because every single one of them has a common factor of 2 on the numerator and denominator, but we're not going to worry about that too much. We're just going to extract the solutions from there as they are. So if you take this to the next step, you would get from here, okay, that x is 2 plus root 16, which is 2 plus 4 over 2, which is 6 over 2, which is 3. Or the other solution is that x is 2 minus 4, okay, over 2, which is minus 2 over 2, which is minus 1. Okay, now you can see from the graph that the solutions are -1 and 3 anyway, and you also could have factorized this one. And the way that I know it could have been factorized is because the discriminant, okay, is a square number. So the discriminant is 16, which has an exact square root of 4 in this case, and that's why I know it could have been factorized. And I can show you here the factorization, which you should easily be able to do now. It would be x minus 3 times x plus 1 and equaling 0, and that would give rise to x being equal to 3 or x being equal to -1, as we've discovered here using the formula. So all that's telling us is that we could have factorized it. We chose to use the formula. We got the exact answers from the formula, and we can see on the graph that it all matches up. Okay. Now the second one we're going to do in the same sort of way, but this time by substituting -1 for C instead of -3, we get a different number under the square root, and we get the square root of 8. Now 8 is not a square number. If you try to take the square root of 8, which is actually 2 root 2, okay, it's an irrational number. It's a number that is not exact. It can't be, well, it's exact, but it can't be written as an exact fraction. All right, so it means that the solutions to this are x equals, well, it's 2 plus or minus 2 root 2, okay, because root 8 is root 4 times root 2, which is 2 root 2, all over 2, and now you can see the common factor of 2, which if I divide numerator and denominator by 2, I get the solutions are 1 plus root 2 and 1 minus root 2. Okay, and those values you could put on the calculator and find out what they are, and you could be asked to give them to 3 significant figures or something like that in the question, or you may be asked just to leave them in that form. But either way, 1 plus root 2 is about 2.4, and you can see that is about 2.4 there, and this is 1 minus 1.4, so it's about negative 0.4 there. Okay, and then you can see that's about right. Okay, so we can find the roots of something that can't be factorized, as in this case you can't factorize this, and I know that because the number under the square root symbol, the discriminant, is not a square number. All right, but we can solve the equation, find both roots using the quadratic formula. Now the third one is interesting because this has a discriminant of 0. All right, now of course you get a rather interesting result with that, because whether or not you do 2 plus root 0 or just 0, 2 plus 0 over 2, or 2 minus 0 over 2, either way you get the same answer, which is that x equals 1, which seems to confirm what we see on the graph here, because it's touching at 1 but it's not crossing to give 2 solutions, so it's only giving one, what we call one repeated root or one repeated solution. Now what about then if you factorize this? Well, you can factorize it, and this is what would happen. The factors of 1 that add up to -2 are -1 and -1. So if you did factorize this, you would have got this: x minus 1 times x minus 1 equals 0. Another name for that is a perfect square, because it means this too, doesn't it? X minus 1 all squared. Okay, now the only value of x that would make that 0, there is only one value, and that is 1. So it's confirming what happened here and what we see on the graph. All right, so if you have a perfect square, then it means that the quadratic is sitting on the x-axis or touching the x-axis but not crossing over it. Now finally we have this one where the graph's been moved up even further, and it appears to be up here in space, coming down as low as 2 but then going up again and never getting near or crossing or touching the x-axis. Well, that implies that it doesn't have any solutions or roots. Well, that's true in as much as it doesn't have any real solutions or roots. Okay, there are such things as complex roots or imaginary roots, which you learn about beyond A level, but for as far as real numbers are concerned, it doesn't have any real solutions. And we know that from the quadratic formula, because look what we have under the square root symbol. We have a negative number. Okay, if you have a negative number under the square root symbol, you can't evaluate it. There's no real number answer to the square root of -8. Okay, and that's the clue that this particular quadratic equation has no real solutions or no real roots. Okay, and of course if you were to try to factorize this, it wouldn't factorize. The only way is to look at the quadratic formula, and in fact you could just look at the discriminant, because as soon as you can see that that is less than 0 or negative, then you know that your quadratic has no roots. Okay, one final thing on this video: we haven't discussed what happens if the x squared coefficient is negative. Simply it means that the graph, instead of being a U shape, would be upside down and would have a maximum peak instead of a minimum peak. Okay, but it can still have 2 solutions, 1 solution, or none. Okay, that's the end of this video. In part 7, we'll have a look at something called completing the square.